In this tutorial, we'll look at wave physics. So wave physics, it has the following components. We have the general waves, electromagnetic spectrum, light wave, and sound wave. In this tutorial, we'll mostly focus on general waves. So let's begin. What is a wave? A wave is a form of energy, is the form of energy that is transmitted from one point to the other in form of disturbances. So in form of disturbances. A wave is the form of energy that is transmitted from one point to the other in form of disturbances. In form of disturbances. That is what gives us a wave. So we are saying it is a form of energy. And how is it transmitted? In form of disturbances. So basically, we have two types of waves. The first one is transverse wave. Then the second one is longitudinal waves. So in this topic, we'll mostly focus on longitudinal wave, on transverse wave. So transverse waves. What are transverse waves? So these are waves whose vibration of particles are at light angle. The other word for light angle, remember, it is perpendicular. At light angle or perpendicular to the direction of the wave. So what it means is this: if this is the vibrating particle, remember, we are saying a wave, transverse wave, these are waves whose vibration of particles are at light angle or perpendicular to the direction of the wave. So if this is a vibrating particle, so this vibrating particle, if it is vibrating like that, then the wave is moving in this direction. So direction of the wave motion. Then this particle is vibrating at light angle to the direction of the wave. It means that this type of a wave is a transverse wave. Remember, it can also vibrate downward, because even here, this and this is forming a light angle. So that is a transverse wave. So what are some of the examples of transverse waves? Examples of transverse waves include number one, it includes water wave. A water wave is just an example of a wave which is formed, for instance, when you drop a stone in water. What you see, those disturbances or the ripples you see there, gives us a transverse wave. So and those, remember, this it is called water wave because these waves are formed in water. Then other than this, we also have another type of the wave, another example of transverse wave, and this one is is wave on a loop. Wave on a loop. For instance, if someone is playing with a loop, then is pushing this loop up, then you see such waves appearing. It means that this type of a wave is a transverse wave. Then the third example, it is electromagnetic waves. Electromagnetic waves. Electromagnetic waves. Then one thing you should know about electromagnetic waves is that they are about 7. So in order for you to remember the memory aid for electromagnetic waves, there's this memory aid. That is the memory aid. Let me write properly. Ramivux. So where AR gives us radio wave, then where this one gives us microwaves, then this one gives us infrared, then this one gives us visible light, then this one ultraviolet, then with this one X-rays, then with the Y gives us the Y rays or gamma rays. So now, how do transverse wave exist? How do they exist? How can I know that what I'm dealing with a transverse wave just by looking at the diagram? So one thing you should know is that transverse waves, they exist in form of crest and trough. So let's look at the diagram below in order for us to understand the point clearly. So if this is my waveform, the upper part is called the crest, then the lower part is called the trough. Then again, I can also have the crest, depending with the number of complete waves that I have. So even this one becomes the trough as well. So that is how a transverse wave exists. Thank you very much. We'll see you in the next tutorial.